Hey everyone, welcome to Unshackling Sudokus and Puzzles. I'm Kishore and today I'll be solving a variant Sudoku sent to us by Tyrgannus. This Sudoku is titled Geode and it looked really interesting, so I thought of making a video on the Sudoku. You'll find the link to solve this in the description, and I'm right now jumping into the Sudoku. It is an irregular plus window combination, that is each row, each column, and instead of 3 by 3 box, each of these irregular shaped regions, which are marked by thick borders that you see here, will have digits 1 to 9 without any repetitions. In addition to that, all these dotted cages, we have 4 dotted cages inside the grid. These will also have 1 to 9 without any repetitions. So these are the rules. With that, we'll start the Sudoku. Thanks Tyrgannus for sending us this Sudoku. This is a live solve. Let's see how it goes. Okay, the first thing I see is, look at this cell, which is row 3, column 3. It is going outside from the first 2 columns, and it is being compensated by a cell which comes inside, row 1, column 2. So I'm saying that row 1, column 2 must be equal to row 3, column 3. The reason is, we know that column 1 and column 2 will have 2 sets of the digits 1 to 9, out of which the first set from 1 to 9 would be inside this region. The second set of digits is almost covered by this pink region, but it is losing 1 digit outside, right? We know that all these cells in the pink region will be distinct because it's inside the region marked by a thick border. So which means that it is losing 1 cell outside. So in order to compensate the cell which goes outside, it must be substituted by the same value which comes inside. So this is called the law of leftovers. It is being commonly used in irregular Sudokus, an excellent trick to solve, to use when you solve irregular Sudokus. Often higher pointers will have tricks like these. So for now, we'll just use these 2 colors, denoting that these 2 are the same. And similarly, in column 8 and column 9, you will see that this purple cell goes outside, this purple cell comes inside. So these 2 are equal. And do we have that in the top rows? No. Okay, so if you imagine a line between rows 5 and 6, you'll notice that the cells which are going outside are, these are the cells which are going outside, the ones highlighted in yellow. And now it is being compensated by 3 cells which is coming inside that, these 3 cells. So using the same idea, if you consider rows 6, 7, 8 and 9, there will be 4 sets of digits 1 to 9, and out of which 3, it is losing 3 cells from these irregular shaped regions, right? So those must be compensated by the same 3 cells. So I'm saying that row 5, column 2, column 3 and column 9 must be the same as row 6, column 5, column 6 and column 7. So again, in-out rule being used here. So which means that 1 must be in these 3 cells. Okay, so where does the 5 go inside this region? It can't be in column 8, it cannot be in row 4. So there are only 2 cells left for the 5. So 5 goes in these 2 cells. Okay, so one more interesting thing is, I have too many colors here, so I need to remove some of these colors to explain this. So for now, I'll remove these colors, I'll put them back, So look at columns 2, 3 and 4. This cage contains one set of digits 1 to 9. This cage contains another set of digits 1 to 9. So we know that columns 2, 3 and 4 will have three sets of digits 1 to 9. So which means that these 9 cells will also have digits 1 to 9. The cells in, you can say light, what is this color? I'll call them orange maybe. The light orange cells will also have digits 1 to 9. So this idea is also used in Windokus a lot. So which means that you can't have one in row 1 in these three cells, that is row 1, column 2, column 3, column 4, and one cannot be in row 5, column 2, column 3, column 4. So which means that for the orange cells, one has to be here. Okay, so I'll remove these colors. We just need to remember them. Okay, I'll remove the pink cell. And I'm removing the pink from this cage. And similarly, we can use that along cages in column 6, 7, 8, which means that these cells will also be containing digits from 1 to 9. So I'm going to remove these colors for now. We just need to remember them. Okay. And similarly along rows 2, 3 and 4 there are two cages, so which means that the cells outside those will have exactly one set of digits 1 to 9, and similarly this will be true. Okay, so one more additional deduction that we can make here is, we know that the entire grid contains digits 1 to 9 times. So we have 4 cages here which will have 4 sets of digits 1 to 9. The light orange contains 1 to 9 once, the pink contains 1 to 9 once, the red contains 1 to 9 once, and green contains 1 to 9 once. So which means that the remaining left out white cells here, so which I'm going to color, will also take digits 1 to 9. So this is something which one often doesn't use, but this is also an extremely good deduction. All the yellow cells will also have 1 to 9. Now it's time to see how we can use all these deductions together. I don't think this is going to be an easy Sudoku at all. Okay, the yellow cells take 1, 6, 9 once already, so which means that 1, 6 and 9 can't be present in them. This is good. In the green cells, where does the 2 go? The 2 cannot be in column 9. The 2 cannot be in column 1, 2 because of the 2 in row 7, column 2. So which means that the 2 in the green cells have exactly 2 options, either in row 6, column 5 or row 8, column 5. Only 2 options. Okay, where does the 6 go in the pink cells? It cannot be in row 9, it cannot be in row 5. So the 6 in the pink cells would have to be in these 2 cells. Ah, okay. So if you look at the bottom irregular shape region, 2 cannot be in column 9, 2 cannot be in these two cells. So there is exactly one cell left for the 2, which is row 8, column 8 must be a 2. There is no other cell left which can take a 2. And which means in this top cage, the 2 has to be in these 3 cells. Ah, that is nice. Now, because of the 2 in row 8, column 8, we can get the 2 in the green region. So the 2 goes here and that reduces 1 into one of these 2 cells. So which means, so remember that these 3 cells, which are row 6, column 5, 6 and 7 must be the same as row 5, column 2, column 3 and column 9, which we saw at the start. So which means that this has to be a 2, because these, I don't know how to highlight them because we have already colored them. So because these 3 cells have a 2 in them, these 3 cells must also have a 2, and 2 cannot be in column 2. So 2 has to go here. Okay, so which means that in the top left cage, the window, there is only one cell left for the 2. 2 cannot be here, 2 cannot be here because it's in the same region, so 2 has to go here. So, and that removes the 2 from these cells, giving a 2 here. So I think we can get all the 2s now. 2 in row 1 goes here, only one cell left. And the 2 in row 9 has to go here, just one cell left in row 9. So we got all the 2s now. So it's important to hit the Sudoku where it is the weakest. So remember that row 3, column 3 is the same as row 1, column 2. So we can write some digits here. These can only be 5, 8 and 9. So I'm not even sure where to look now because okay, look at the top. Oops, why is the window changing? Yes, look at the top right cell, row 1, column 9. It cannot be 1, 2, 6 and 9 or 3 and 8. So it is 4, 5, 7. And similarly, the leftmost cell, row 9, column 1, it cannot be 1, 2, 6, 9, 4 and 7. So it's 3, 5, 8. The 4 in the lower left cage must be in these 3 cells. Okay, the 5 in this zigzag shaped irregular region at the middle, right at the middle. I'm not sure why the cursor is not showing. It is a problem with Mac, I think. The OBS is unable to show the cursor. So I'll just reside the cells. The 5 in the middle region must be in row 5, column 4 or row 5, column 6. Just 2 cells. Okay, it cannot be in, or can it be? No, wait, I just saw something imaginary there. Not so easy here. Okay, I'm looking at row 6 column 1 and asking myself what can go there. It cannot be 2 4 6 7 3 5 or 8 because 8 is already in the green region, so it can only be 1 or 9. And 1 is in one of these two cells that we have marked in the same row, row 6 I mean. So this cannot be 1, so that's a 9 now. Superb. Okay, now row 7 column 1, just writing some candidates there, 1 3 5. Okay, look at row 6 column 9 and it is part of a green region, so it cannot be 2 4 8 9 1 and 5, so it is 3 6 and 7, and 3 is also ruled out, 6 and 7. Okay, row 8 column 9 cannot be 2 4 8 9 1 or 5, it's 3 6 and 7. Okay, row 4 column 1 has to be 1 3 and 8. So where does the 9 go in the red cells? You can notice that 9 can only be in row 3 column 9 or row 4 column 9, because it cannot be in column 5, it cannot be in column 1 in the red regions. So 9 has to be here, and that puts the 9 in row 7 in these two cells. Very well. Okay, so I'm looking at row 5 column 2 now. It cannot be 1 2 4 6 and 9. It also cannot be a 5, so it is 3 7 8. So I know I'm just going randomly here, but it's really difficult to solve it in the exact, or rather let me put it this way, it's very difficult to solve it in a clean way without becoming messy. And row 5 column 8 is 4 7 and 8. Okay, row 9 column 9, it cannot be 1 2 5 8 9, so it's 3 4 6 and 7, and 6 is already in the yellow cell, so 6 is not here. 3 4 and 7. Look at row 4 column 8, it can only be 6 7 and 8. It's time to make a move now. Okay, the 1 in row 2 must be in these three cells. I mean, in this region, 1 must be in these three cells. So that puts the 1 in the top right cage, must be in these two cells. Not even sure what to look. I'm looking here and there. It doesn't. I'm not able to get anything here. Is there something that we can use? Okay. These three cells, I'm running short of colors here. I don't even know how to explain this. These cells in column 8, row 2, row 3, row 4, the ones I have highlighted in yellow now, must be the same as row 1, column 7, row 3, column 5, and row 5, column 7. Because these three cells cannot be the same as these 6 cells, which means that these 3 cells must get distributed into these cells. So now the 3 has to be in one of these pink cells. Okay, it's not much. So which means that 3 in the bottom right cage has exactly 2 cells left. So 3 has to be here. Okay, row 2, column 1 must be 3, 5, and 8. 1 is already eliminated from there. Okay, where does the 1 go in this region? The irregular shaped region, there is exactly 1 cell left. 1 cannot be in row 2, and because of these ones, 1 cannot be here. So there is exactly 1 cell left, which is row 4, column 1. 1 cannot be anywhere else. So that removes the 1 from row 7, column 1, 3, 5. And now the 1 in the green cells must be in one of these 2 cells. And that removes the 1 from row 2, column 5. Okay, so row 3, column 2 must be 5, 8, 9 now. And that gives a 3 in this domino. One of these cells must take a 3. And 1 in the bottom irregular region, the left bottom irregular region must go into these 2 cells. Can't be anywhere else. Okay, where does the 9 go in row 4? There is exactly 1 cell left. It cannot be in row 4, column 3, column 4, column 5. So 9 goes here. We got the 9s in the red cells. Okay, the 3 in row 4 has exactly 2 cells left. And which means row 4, column 3 must be 6, 7, 8. So how long have I taken on this Sudoku? It's 23 minutes, not bad. Okay, 1 is in these 2 cells, right? So which means 1 cannot be in row 6, column 2. That gives a 1 here, right? So we get the 1 in row 8, column 2, and that removes the 1 in this green region. Let's just place the 1 here, and that removes the 1 from row 9, column 3, and places the 1 in row 9, column 4. So we got all the ones, if I'm not wrong, except these 2, right? Okay, row 6, column 2 has to be 3, 7, and 8. There's no 5 there. So 5 in column 1 must be in these 2 cells, and that removes the 5 from row 2, column 1. So it becomes 3, 8. Okay, 3 is not in row 6, column 2. That's 7, 8. And row 5 column 2 cannot be a 3 as well, because that would place a 3 in these three cells, right? Remember, we use the in-out rule, and which means you can remove the 3 from row 5 column 2, and that gives a 7-8 pair in this region. So which means this will be a 3-5, giving us an 8 here, and that means this will be a 5-9 pair, giving us a 3 in row 2 column 2, and that's 5-9 row 1 column 2, and 3 is not in row 4 column 4 anymore, because this is part of a single cage. So 3 goes here, we got the 3 in the red region. Row 4 column 4 is 6, 7, 8, and 8 cannot be in row 2, so 8 goes in this domino, which means this is not 8. Okay, row 8C5 column 5 must be 5, 6 and 7. Consider in terms of the green region, only it can contain 5, 6 and 7. Okay, so row 6 column 6 and 7 must be 1, 7 and 8, right? The reason is, using the in-out rule again, row 5 column 2 column 3 and column 9 are going outside, and row 6 column 5 6 and 7 are coming inside, so they must be equal, and I've just made the pencil marks based on that. So that means we have a triplet of 1, 7, 8 in that row, which means this will be a 6, this is not a 6, row 8 column 9 is not a 6, 3, 7, and we can place the 4 in row 6 now. And which means there is only one place for the 4 in this zigzag kind of region right at the center. 4 cannot be here, 4 cannot be here, so 4 has exactly one cell left. That gives a 5 in that region, and 4 is not in row 5 column 8, so that allows us to put a 3 in that row. This is not a 3 anymore. Okay, where does the 4 go in the bottom right cage? 4 cannot be in column 6, 4 cannot be in row 8, so which means we have a pair. So that means we get a 4-9 pair here. That's good. And that eliminates 4 from row 9 column 9. So 3-7 pair, which means the top 2 cells we can make a pair again, 4-5. And this will be 6 and 7. So where does the 8 go in the top right region? So 8 has to be here, and that gives a 7 in row 5 column 2, that gives 8 here, which means this will be a 1-7, and that means these 3 cells for the cage must be 3, 6 and 8. And look at this lower left cage, the only digits left are 5, 6, 7, 9. 5 cannot be here, and which means for this region as a whole, 8 must go here, row 9 column 3, and that gives 8 in row 4, that's 6 and 7. Okay, this becomes a 1, 6, 7 now. So where does 4 go in column 3? Exactly one cell, row 1 column 3, and where does the 1 go in column 3? Has to be here, right? We're getting good progress here. And look at row 2, there is a 6-7 pair, which means the remaining cells must be a 4, 5, 9, and 4 cannot be in row 2 column 5, row 2 column 6, so 4 has to go here, and that resolves this 4, 9 pair. So I think we can race through the Sudoku now. Column 8 can be completed. It's a 9. Okay. In the region where we just placed a 9, we have a 3, 6, 8 and a 1, 2, 9. So remaining are 4, 5, 7. 4 goes here. And this will be 5, 7. And this will be a 5, 7. Okay. 9 in column 5 resolves this 5, 9. So that's a 5. That's a 9. Which means row 8, column 5 must be a 7. That's a 5. And 3, 7 here can be resolved in column 9. So this is 3, this is 7. And 3 can be placed here now. That's a 3. That's 6, 8. So which means row 8 can be filled. 5 and 9. That gives us a 6, 7 here. And these can be instantly resolved because of the 5 already there. So that's 5, that's 9. That's 9, that's a 5, that's a 9, and this 5 can be placed, that is a 4. Row 1, column 9 is a 5, and these will be a 1, 8 pair, can be resolved. Not yet. So this is 6, and column 5 can be completed, 8. Okay, column 4 can be completed, that's 3. This will be a 6 or a 7, and that will be a 6 or a 7. Okay, 3, 5 in column 1 can be resolved, 5 and 3. Okay, what does row 4, column 3 contain? You already have a 7, 1, 7 pair in that region, so this will be a 6, which means this will be a 7, this is a 6, this is a 7. And the 7 in row 2, column 4 means 6, 7 can be resolved in top row. So 6, 7, 7, 1, 1, 8, and 8, 6, 7, 6. And with that, we have completed this Sudoku by Tyrgannus. An excellent one, I would say. The colors kind of made the solve a bit difficult, but if you're solving on paper, you can try to remember things and solve, and that I think would be easier. But an excellent Sudoku by Tyrgannus. Thanks once again to the author for sending us this Sudoku. If you did enjoy this Sudoku, please subscribe to the channel and do become a patron of the channel. We'll be giving some rewards to our patrons soon in the form of bonus Sudokus. May not be regular, but we are planning to give something, so please consider supporting us on Patreon. We'll see you soon.